When you're first learning about motion, sometimes the difference between velocity and acceleration is pretty confusing. I like to keep track of them by thinking about the velocity as telling me what the object is doing, and the acceleration is all about what the object is about to do, what it's going to do next. I have a ball here in my hand, and I'm going to exert a force on this ball. At the moment, the force is exactly equal to the force of gravity, but in the opposite direction. So I push up on the ball, and gravity pulls down on the ball, and then it just sits there. If I push up harder, the ball moves up, and if I push down not as hard, the ball moves down. If I toss the ball in the air, as soon as it leaves my hand, the only force acting on the ball is gravity. Gravity pulling it downward. So I toss the ball again, and I want you to think hard about what's going on at the top of that toss. Right there at the top of the toss, the velocity of the ball is 0. It's stopped. That's what it's doing. It's just sitting there at the top. But what is it about to do? Well, it's about to fall. So the acceleration must still not be 0. So right there at the top, the velocity goes to 0, but the acceleration stays the same, so the ball comes back down again. It might seem kind of strange to you that an object could have 0 velocity, but not 0 acceleration. I have another demonstration for that. Here I'm standing, just standing still. If I have no acceleration, I will continue to just stand still. I don't go anywhere. I never get started going anywhere because both my velocity and my acceleration are 0. In order for me to go somewhere, I have to actually start moving. There has to be a moment when I'm about to go. So I push back on the earth pushes forward on me, and I have an acceleration that's sending me forward. And then I have a velocity. So I have a non-zero acceleration that leads to a velocity. That acceleration is telling me what's about to happen. The force, the mass, and the acceleration are all related to each other. So when I exert a force on an object, the acceleration that it experiences depends on the mass. Here I have a little car on this track in front of me, and I can push on this car with different forces. The car has just one mass, it's the mass of the car. If I push on the car very lightly, then I'm going to expect it to accelerate, but not much. And it does that. If I push on the car harder, what do I expect? I expect it to accelerate more, because it still has the same mass. So here now I'm going to push on the car harder, and it accelerates more, just as I expected. To figure out how the mass matters, we need to have a way to hold the force constant. And these cars come built in with a way to hold the force constant. They have a little rod stuck inside them with a spring, and if I push this button, the rod shoots out, and it always shoots out with the same force because it's loaded from a spring instead of from me pushing it. So I'm going to push that rod back inside, and I'm going to go ahead and set it against this stopper, and I'm going to push that button. And we expect to see the car accelerate that direction. So let's see what happens. It accelerates pretty quickly. That rod exerts a pretty big force on the car. Now I'm going to push this back in, and I'm going to add some mass to the car. So now the car is going to be heavier. It's going to weigh more, and it's going to have more mass. So I put the mass in the car. What do we expect? What we expect is that because the car is more massive, that same force is going to accelerate it less. So let's see what happens when I push the button. The car accelerates less. The force, the mass, and the acceleration are all related to each other. A bigger force on an object of the same mass produces a bigger acceleration. The velocity and the acceleration are two different things. The velocity tells you about what the object is doing, and the acceleration tells you what the object is about to do.